students, how are you all? I hope you all are fine. This is your science lecture of grade 5th, and I am your science teacher Aparna Pandey from Arjun Progressive School, Lamachur. So student, as you all know that in science, we are discussing our chapter number 7. In science, we are discussing chapter number 7 and its name is Air and Water Essentials for Life. The name of chapter number 7 is Air and Water Essentials for Life. So in this chapter, till now we have learned what is air, composition of air is necessary for breathing. Then different properties of air, that air occupies space, air has weight, air exerts pressure in all directions, right? And these all things we have discussed related to air. Now, as when we have studied the properties of air, we also come to know that air exerts pressure, and in general we say that it is called atmospheric pressure. The pressure which is exerted by air is called the atmospheric pressure. Then in previous class I have also introduced you with a device called barometer. A device called barometer is used for measuring atmospheric pressure. So these all things we have discussed in our previous class. Now student, in today's class we are going to learn the use of atmospheric pressure in our daily life. How we use, what is the use of atmospheric pressure. So in today's class we are going to learn use of atmospheric pressure. So how this atmospheric pressure is useful in our daily life. So then, as in our daily life we are dealing with many things which are actually working due to the atmospheric pressure, but we are applying that we are using the items, we are doing things related to atmospheric pressure, but we don't know. So I am going to tell you today some examples where atmospheric pressure is applied in the things, and by making the use of that atmospheric pressure, we are doing our daily work. So, for example, first is filling medicine in a dropper. Okay, the first example is filling medicine in a dropper. Filling medicine in a dropper. So beta, actually what it is? See, I hope that you all have seen dropper. If you have young brothers and sisters, so I hope that you have seen that your parents are using dropper to give medicine to them, or in many cases in medicines droppers are there. So actually how this dropper works. So now today we are going to learn that how this dropper functions. So beta, see, the filling of medicine in a dropper is actually occurred due to atmospheric pressure. The filling of medicine inside a dropper actually occurs due to atmospheric pressure. So how it works? See beta, I hope that you all have seen dropper. So this dropper, what happens when we push the rubber of the dropper? When we push the rubber of dropper, what happens? The air which was inside the dropper comes out. The air which was earlier filled inside the dropper comes out. Now what happens? The air pressure inside the dropper decreases. Pressure outside the dropper is high. The air pressure inside the dropper is low. because as soon as we have pressed the rubber of a dropper, air comes out. So now air pressure inside the dropper is less and air pressure outside the dropper is more. So when we put that dropper inside the medicine, because in that medicine air pressure is more, so from there that air pressure or that atmospheric pressure pushes medicine up in the dropper, and in this way we are able to fill medicine in a dropper. Okay, so I hope how the filling of medicine in a dropper takes place, you all are getting this. This filling of medicine in a dropper is due to the difference in the atmospheric pressure inside the dropper and outside the dropper. Because as soon as we have pressed the rubber of the dropper, air comes out from the dropper and the air pressure inside the dropper decreases. But when we have dipped that dropper in a medicine, so inside in that medicine bottle air pressure is more as compared to the pressure of the dropper. So due to that, pressure in the medicine bottle is high, which pushes up the medicine. So in this way we are able to fill medicine in a dropper. In same manner, we are also able to, the same principle works for filling ink in a fountain pen. Ink in a fountain pen. So how we are able to fill ink in a fountain pen? So this also. Ink in a fountain pen, this is also works on the principle of difference in atmospheric pressure outside and inside, right? Now students, one more example is there where we use atmospheric pressure in our daily life. It is filling of syringe. Filling of syringe. Third I can say filling of syringe. So what is this filling of syringe actually? Filling of syringe also functions on the principle of atmospheric pressure. So what happens in this case? See beta, as we take syringe and we want to fill medicine inside the syringe. So what we do? First of all, we push the piston of the syringe inward. As we push the piston of the syringe inside, what happens? The air inside the syringe comes out from the hole. Okay, where is the hole? Where needle is there. So from that hole, the air which was earlier inside the syringe comes out. Now again what happens? Now the syringe is having low air pressure and outside the syringe there is high air pressure. So when we put that syringe inside the bottle from where we have to take the medicine inside the syringe, there the level of atmospheric pressure is more. As we pull the piston up, what happens? Due to the atmospheric pressure, the medicine fills, the medicine comes up in the syringe. So in this way, we are able to fill syringe. Let's see what is given in your book. It is saying, filling medicine in a syringe. Doctors use syringe for injections. The medicines in the syringe is also filled due to air pressure. When we push the piston of the syringe inside, when we put the piston of the syringe inside, air is pushed out through the narrow hole, as I told you. When we put the needle in the liquid medicine and put handle outside, air pressure pushes the medicine in the syringe. So in this way, we are able to fill medicine in syringe. I hope it is clear to everyone. Now, third, we have discussed the fourth thing where we use atmospheric pressure in our daily life is in drinking liquids with the help of a straw. So, using straw for drinking, using straw for drinking. So, when we use straw for drinking, at that time also, when we use straw for drinking, at that time also, actually atmospheric pressure is working. See how? As soon as, suppose you want to drink cold drink. So, as soon as you have use straw, you want to drink cold drink with the help of straw. So when you start sucking straw after putting it in a liquid, what happens? As you suck the straw, the air inside the straw is solid. Solid means वो आप ले लेते हो अपने अंदर. So the air that inside the straw is solid. Now inside the straw, because earlier the air was there and now you have swallowed that air, so atmospheric pressure inside the straw is less and the atmospheric pressure outside the straw, inside the glass of cold drink, it is more. So due to this, what happens? The more atmospheric pressure area where cold drink is there, that cold drink is pushed inside the straw with the help of the difference in atmospheric pressure. Because inside the straw, atmospheric pressure is less and outside the straw, inside the glass, atmospheric pressure is more. So liquid moves from more atmospheric pressure to low atmospheric pressure. And in this way, we are able to drink cold drinks with the help of straw. Now, one more important use of atmospheric pressure that we do in our daily life is we use siphon for putting liquid from one container to another, or we use siphon for transferring the liquid from one place to another. So what it is? Let's see. Use of air pressure in our daily life is that air pressure forces liquid to a siphon. Air pressure forces liquid. Air pressure forces liquids through siphon. Through siphon. So what I have written here, students? Air pressure forces liquids through siphon. This is the another use of air pressure, that it forces liquids with the help of the siphon. Means by using siphon we can transfer liquid from one vessel to another vessel, from one container to another container, from one place to another place. So, before going through it, first of all, we must know what is siphon. A siphon is a tube. Siphon is a tube which is made up of either glass, metal or rubber. Siphon is a tube which is made up of glass, metal or rubber, and it has one arm long and another arm short. Okay, its one arm is long and another arm is short. For understanding more about the siphon, let's discuss first diagram of the siphon as well as its functioning. Then only you will be able to understand that how air pressure forces liquids through siphon. एयर प्रेशर साइफन से लिक्विड्स को फोर्स करता है एक प्लेस से दूसरे प्लेस में जाने के लिए. ठीक है, दिस वी गॉट. बट इस समय जो मोस्ट इम्पॉर्टेंट इज साइफन. एंड व्हाट इज साइफन? Then only we will able to understand the functioning of working of air pressure and the working of air pressure or role of air pressure in siphon. So first of all, let's know something more about siphon. So students, siphon is used to draw liquids from big vessels. It is a tube of glass, metal or rubber. The tube has a shorter arm and a longer arm. As you can see in the diagram, the tube has a shorter arm and a longer arm. The shorter arm of the tube is put in the liquid in a big vessel. Okay, big vessel means where more liquid is there. So we have put this longer arm, we have put the shorter arm in a container which contains more liquid. Now the longer arm is put in the empty container. Empty container means khali. As you can see the another container where liquid is falling down, so actually earlier it was empty. पहले वो खाली था. Now it has start collecting liquid. So the longer arm is put in the container to collect the liquid. Now what happens? As soon as the air is sucked from the longer arm, the pressure inside the tube decreases. जैसे ही air क्या होती है हमारी sucked होती है longer arm से, तो pressure in the shorter arm decreases, and due to which the liquid rises in the tube from shorter end and starts coming out. अब क्योंकि shorter arm में क्या होता है air pressure कम हो जाता है, तो वहाँ से हमारा liquid rise होना शुरू कर देता है and it starts coming out. अब लिक्विड बाहर कहाँ से आएगा? लिक्विड विल कम आउट फ्रॉम द लॉन्गर आर्म एंड देयर वी कलेक्ट इट इनटू द अनदर वेसल. इन दिस वे इट कंटिन्यूज टू फ्लो अंटिल द लेवल ऑफ टू वेसल्स बिकम इक्वल और कंप्लीट लिक्विड इज ड्रॉन आउट. तो दो केस, या तो जब तक पहला बर्तन दूसरा बर्तन भर ना जाए तब तक लिक्विड आएगा, या फिर जब तक लिक्विड खत्म ना हो जाए तब तक लिक्विड फ्लो करेगा. So student, I hope that you all are able to understand what is siphon, what is its long arm, what is its short arm, and I hope it is also clear from the diagram that short arm we put in a container containing liquid and long arm we put in a container where we want to collect liquid, right? This much I hope it is clear. Now let's see how this works. So let's see what is given in your book. As you know, it has two arms, longer arm and shorter arm, right? So, air is sucked from the longer arm. Air is sucked from the longer arm. The pressure inside the tube decreases and the liquid rises in the tube from shorter and starts coming out. अब ये आपको सबको पता चल गया. As soon as we suck a tube, air pressure of the tube decreases. अब क्या हो रहा है, यहाँ पे हम लॉन्गर आर्म से एयर सक कर रहे हैं. तो जैसे ही हमने लॉन्गर आर्म से एयर सक करी, क्या हुआ? द प्रेशर इन द लॉन्गर आर्म डिक्रीजेस. द प्रेशर इन द लॉन्गर आर्म डिक्रीजेस, ड्यू टू विच व्हाट हैपेंस, द प्रेशर इन शॉर्टर आर्म becomes more, due to which liquid starts moving from shorter arm to the longer arm, right? Now, the liquid is collected in the other vessel at a lower level. The liquid which is coming from the shorter arm, that liquid when it comes out from the longer arm, we collect it in another vessel which is collected at a low, and the vessel is kept in a lower level. It continues to flow until the level of two vessels become equal or complete liquid is drawn out. अब ये कब तक प्रोसेस चलता रहेगा कि ज़्यादा शॉर्टर आर्म से लिक्विड सक होगा, लॉन्गर आर्म तक आता रहेगा? ये तब तक होगा जब तक दोनों वेसल्स के लिक्विड का लेवल या तो इक्वल ना हो जाए, या फिर देयर मे बी अ चांस कि एक में से कंटेनर में से लिक्विड फिनिश हो जाए और दूसरा कंटेनर फिल हो जाए. So in this way, air pressure forces liquid through siphon. So I hope this is also clear to everyone. Now, one more example is there where we use air pressure, and it is air pressure helps in pushing the things. Air pressure helps in pushing a thing. So we can say air pressure pushes things. Air, is it visible? Okay. Air pressure pushes things. Air pressure pushes things. So let's see that how this air pressure pushes things. due to the air pressure, things starts moving. For example, sailboats. Sailboats move due to the air pressure. Sailboat moves from one place to another place due to the air pressure. Similarly, windmill. Windmills also work due to the air pressure. As well as flying kites. Flying kites, kites which you fly are also work in the air pressure. They also fly due to the air pressure. So these are the things like sailing boat, windmills, flying kites. These all are actually using air pressure for functioning. So students, in today's class, we have learnt the different types of uses of atmospheric pressure in our daily life. What are these? We use atmospheric pressure for filling medicines in a dropper. We use atmospheric pressure for filling ink in a fountain pen. Then we use atmospheric pressure for filling medicine in a syringe. Then we also use atmospheric pressure for drinking liquids with the help of the straw. Then we use atmospheric pressure for pushes the things from one place to another like boat, windmills and kites. Similarly, siphon also uses atmospheric pressure so that it can help in shifting the liquid from one vessel to the another vessel. So these are the different areas of our daily life where we use atmospheric pressure. So students, I hope topics that I have explained today you all are getting that. I hope you all will like this video.